Good morning. I am Vedaraj, Associate Professor, Department of Computer Science Engineering, RMD Engineering College. In this session, we are going to discuss what is Snapshot Recording Algorithm. First, we are going to discuss about the system model of Snapshot Recording Algorithm. The system consists of collection of n number of processes, P1, P2, up to Pn, that are connected by the communication channel. Consider Cij denote the channel from process Pi to process Pj. Process and channel have state associated with them. The state of the process is defined by the content of the processor register, stacks, local memory, etc. The state of channel Cij denoted by Scij is given by the set of messages in transit in the channel. In the FIFO model, each channel acts as the first in first out message queue. Message ordering is preserved by the communication channel. In non-FIFO channel, a channel acts as the set in which the sender process can add messages and receiver process remove messages from random order. Again, I tell you what is the difference between FIFO channel and non-FIFO channel. In FIFO channel, every channel acts as the first in first out message queue. The message ordering is preserved by the channel. What order the message is sent, the same order the message is received by the process. Ordering is preserved by the communication channel. In non-FIFO model, the channel acts as a set. The sender process can add a message and receiver process remove a message in random order. Okay, this is the system model of snapshot recording algorithm. Why do we need snapshot algorithm for FIFO channel? Okay, the snapshot, it's mainly used to capture the local state of each process along with the state of each communication channel. Okay, why do we need snapshot? Snapshot is required for four important purposes. One is the checkpoint to save the current state of the process and channel. The second one is collecting the garbage. The third one is to detect the deadlock. Fourth one is debugging. Okay, now we are going to discussing about how the communication, how the Candy and Lamport algorithm can work. Before we are entering the Candy and Lamport algorithm, the Candy and Lamport algorithm record the set of process and channel state such that the combination is global state, communication channel assumed to be FIFO. Okay, we already discussed why do we need snapshot recording algorithm. The four assumptions are very important. Number one, there is no failure in process and channel. Number two, communication channel are unidirectional and FIFO channel. Number three, there is a communication channel between every para process. Number four, any process may initiate the snapshot. Okay, now we are going to discuss about the example of snapshot recording algorithm. Consider there are two processes P1 and P2. Okay, initially P1 have the marker message. Okay, P1 have the $1,000 no widget. P2 have $50 and 2,000 widget. Okay, first P1 have the marker message. The P1 record its state. What is the P1 state? The P1 have initially $1,000 zero widget. Okay, then P1 send a marker message to P2 before sending any application oriented messages. Okay, P1 send a marker message to P2. Then third step, P2 state is not already recorded. Okay, P2 is newly received the marker message. Okay, so P2 first record its own state. Okay, so what is the P2 state? P2 state is $50, okay, 2,000 widget. So P2 state is recorded. After P2 record its state, P2 send a marker message to P1. But P1 state is already recorded. No need to record your P1 state. So P1 record it's the channel state. Okay, C2 state is recorded, then C1 state is recorded. Okay, this is the example of snapshot recording algorithm. Again, I tell you, process P1 recorded state in the actual global state is 0 when the state of the P1 is $1,000 and 0. Following the marker sending rule, the marker sending rule is nothing but, so first the process record its own state, then it send a marker message to P2. Okay, so there are two important rule plays a two important rules of snapshot recording algorithm. One is marker sending rule, another one is marker receiving rule. The marker sending rule is nothing but process P1 record its own state, then send a marker message to P2. Marker receiving rule is nothing but when P2 receive a marker message, if the state is already not recorded, first P2 state is recorded, then it mark a channel status empty. If the state is already recorded, no need to record the state again. It record the channel state, what is the message received over the communication channel. See, this is the algorithm. See, marker sending rule, process PI recorded state, then it send a marker message to other process before it sending any message. So marker receiving rule, when a process PJ receive the marker message, if the state is already not recorded, it record its own state, mark a channel status empty. If the state is already recorded, it start recording the channel state, what is the message received over the communication channel. Thank you.